Okay. Good afternoon, everyone, and welcome. Thanks for joining us today's webinar, co-hosted by Maxisafe and Dustlight. Over the next 20 minutes, you'll get a clear, practical overview of why dust monitoring matters and how to detect harmful particles in the workplace to keep teams safer. We're going to run through a short presentation and then move into a Q&A at the end. You'll see a Q&A bottom at the bottom of your screens, you'll see a Q&A button at the bottom of your screens, and feel free to submit questions at any time. We'll answer as many as we can today and follow up on any we don't after the session. I'm delighted to introduce our speakers today from Dustlight in Germany. Till is the CEO and co-founder of Dustlight, and Benjamin is the head of product at Dustlight. I do apologise. Sabrina wasn't able to join us today. She's quite unwell. But we're in the safe hands of Till and Benjamin, who will hand over to start us on the Dustlight presentation. Thank you both.
Thank you. Thank you. All right. Good morning, everyone, also from our side. Yeah, I'm very sorry that you're seeing myself right now, not Sabrina. But as you can imagine, the German summer lets you get the flu. It's very rainy here right now. Nothing compared to the Australian summer. So yeah, we have to excuse her, but I'm very sure that Benjamin and myself can answer all of your questions and hope to give you a very interesting presentation. Yeah, thank you, Hazel, for the welcome. As Hazel mentioned, there's a Q&A button at the bottom with the question mark. If you click on it, you can type in questions. We will try to answer most of your questions whilst we go through the slides in the first place anyways, but we have a saved time slot in the end of our presentation to really go through them and try to answer all of them. If we aren't able to go through them and answer a question, we'll try to make sure to get to you afterwards and then answer them for you. Also, if anything is unclear, feel free to write in your question. And with this being said, let's jump right in. We got quite a number of viewers today. So I'm really looking forward to this session and hope that you enjoy it and take something away for yourself. All right. So with this, can you see my screen? Benjamin, yes. Perfect.
I can see it, so I hope the rest can see it as well.
All right. So yeah, today's session is about Dustlight. With Dustlight, we really have one mission, and I think this webinar today showcased this wonderfully. That's protecting workers all around the globe. Doesn't matter if you're in Germany or all the way on the other side of the world in Australia. We try to be there for you with Dustlight. As Hazel already introduced us, I think I can jump over this very quickly. My name's Till. With me here is today my colleague Benjamin.
Hello
really
to my side.
to have us today. Oh, very grateful that you guys have us today. So, short overview of our agenda for today. The first section is what we call Know Your Limits. We give a bit of an intro into dust. Invisible workplace hazard, how it works, why dust is dangerous. Then, since I think this is one of the most interesting ones for most of our viewers today, we make a bit of a deep dive into silica, something where the Australian safety regulations are very, very aware of. And then we continue. I'm gonna hand over to Benjamin. He's gonna talk a bit about how current monitoring methods are working, telling you a bit about how Dustlight is working, how Dustlight is adding value to the process of measuring dust in workplaces. Then we go a bit on the data side. There's a software with Dustlight which we want to introduce shortly. Don't go in too much of depth. I think we have other webinars planned for this as well in the future, but to give a bit of an overview, and then we round this off with our Q&A session. We try to keep every part of this section to roughly like 15 minutes, so you can have a bit of an overview. All right. So let's jump right in. I think every one of us has seen pictures like this of workplaces, right? You see someone who's, oh, I'm just gonna cut some tiles here. I'm just gonna do this quickly, and then there's no wet cutting of stone slabs. There's no ventilation system when someone's pouring or mixing concrete. When someone's just shortly welding something up, they don't turn on the vacuum, the ventilation system, and then one short work step turns into something like this, where you spend like an hour there. It's super dusty, and it's just not really the way to do it anymore. And this is the first part of our webinar today: know your limits. Dust is not just in one industry, right? We really often get asked, who's kind of like the key customer for Dustlight? Which industry are we serving? And this is not a short answer. This really gives you an overview of different industries, some, not all of them, that we're operating in, right? And you see from mining and construction on the top there, to chemical companies that obviously have lots of dust when they work with powders, to metal industry and more industrial use cases, from production of lithium batteries, to welding huge metal structures, all the way to research and regulation institutes. The ESA is probably not too known in Australia. That's the European equivalent of the NASA. That's the European Space Agency. So this is really kind of like should give you a bit of an overview. The industries that we are serving, and obviously that stands for how many industries there are that have a problem with dust. But to get a bit of an understanding, we want to make a short kind of like overview what dust actually is. And I try to keep this as little as kind of like a school session as possible, but please bear with me. It always looks way more complicated than it is. With dust, you probably really often have heard of values like PM1, PM2.5, PM4, even PM10. And what those mean is PM stands for particle matter, and then the X, the number, really just showcases the diameter up to which the particles go in micrometer, right? And so PM1 means dust particles that go from 0 micrometer to 1 micrometer, right? PM2.5 is then from 0 all the way to 2.5 micrometer in diameter, and so on, meaning PM10 is from 0 to 10 micrometers diameter, and obviously this includes PM1, 2.5, PM4. So all of those values then are in PM10. Another thing that you might have heard, especially if you've read the WES, is respirable dust. Respirable dust is kind of like an equivalent to what we usually have with PM4, right? So those are particles that are so small that if you breathe them in, they would go all the way into your lungs and all the way to your alveoli, and be able to cause serious health risks there over time. Since I started talking about alveoli, you have a picture on the right side here of a human and his respiratory system. So you see the smaller particles get, the deeper they could really penetrate the lungs, and the more dangerous they can be, right? So we always really often hear when we talk to people, for instance, when we talk to carpenters on construction sites, they'd be like, yeah, I know respirable dusts when I kind of like use a napkin and clear my nose after work. What comes out? This is respirable dust, right? And we're like, yeah, technically there might be parts of respirable dust, but really those are usually the particles that are even bigger than PM10. Those are the ones that end up in your nose. And our human body has a very well engineered, if you want so, filter system where the bigger particles really get sorted out. But this system doesn't work for the really, really small and dangerous dust particles. To give you a bit of an more of an oversight of what we actually talk about when we talk about dust and why it's dangerous, we have a little graphic here. Dust can have many different forms, and there's many different risks that can come from this, right? And on our graphic on the left, you can see there's different ways to characterize dust. You can define it by shape, right? Everyone who has a hay fever has heard of pollen. I'm pretty sure all of you have heard of crystalline silica, or probably most of you, right? There's a great picture here from a microscope that really shows you why it's called crystalline silica. It really looks like a very fancy crystal there. And you probably heard about asbestos, right? And you can really define those by shape, where pollen is spherical shape, crystalline is crystal or angular shape, and then something like asbestos is what we call a fibrous shape, right? Which is really like a fiber. And also you can define by material from metal dust. Pretty much when you're welding, this is metal dust as well. Not just next to your CNC mill, but also when you're welding the fumes that go up, that's metal as well, which is inorganic. Then you have wooden dust, that's organic. And really often people say, well, if it's organic, right, like in the food industry, it can't be that dangerous. Unfortunately, that's not true. Wood dust is very dangerous, especially hardwood dust like birch or oak. Even if it's organic, doesn't mean that it composes automatically in your body. Actually, it's the opposite, especially with hardwood. It stays in your lung for quite a long time. Can harm you very much. And then fiber-based like mineral wool, for instance. And all of those different shapes and different characteristics can pose different risks to the human body. From on the top right, you see radioactive. Probably nothing you thought about in the beginning when I talked about respirable dust, but this actually can harm a huge danger. A huge customer from ours is the Center of Nuclear Waste Disposal in Germany, right? Everywhere where they have dust, it can be radioactive dust, something that you absolutely don't want to have in your lungs. Then there's different, carcinogenic dusts like silica dust, quartz, asbestos, where you have really high cancer risks. We have toxic dusts, especially with welding fumes, pardon me, where lead dust or nickel can cause nerve damage. Really, very serious topic. There's different corrosive dusts where you can get kind of like, tissue corrosion, and then you have the fibrogenic dust where, there's different diseases to this one as well. And to round all of this off, we have a little quiz question here for you. So now is the time to open your Q&A window, or I kindly ask you to do so. And our question is, if we have a dust particle, right, that's 1 micrometer diameter, 1 micrometer in diameter, right? Classic welding fume particle would be that size, or silica if you're, sanding concrete, cutting concrete, and those are usually the particles that you have. If I would have one of those on my desk right here, and I would swoop it off with my hand, how long do you think it takes for this one particle, to drop down to the floor to settle 1 meter? So please, now's the time to post in your question. I'll be very excited to see kind of like what you guys are guessing. All right. I see the first answers coming in. So we have everything here from 30 minutes, 1 hour, 48 hours, 30 seconds, 20 minutes, up to 4 days. And first of all, thank you so much for taking part so much in our little questionnaire here. Usually when we have those webinars, well, not usually, but sometimes it happens that we don't get any answers. And that leads to me to asking Benjamin, making sure that he did his homework. But usually he knows the answer very well. So the answer is up to 7 hours, right? So this really gives you kind of like an indicator. If you start working in the morning, right, the first thing you do in the morning can still affect your afternoon shift, right? If you have like two shift system, or it can really affect your colleague that's coming by to your workplace at the end of your shift, right? And this is 1 meter is 7 hours. So imagine if you cut something a bit higher. We actually have had a carpenter shop in rural Bavaria, rural southern Germany, reaching out to us on a Monday morning, telling us, "Hey, can you explain this to me? I just came into the workshop on a Monday morning and the device turns up red. How can this be?" And then we realized, hey, this was winter, there was no ventilation. The last thing on a Friday, what he did was taking a broom and kind of like cleaning his workshop. And then there's a heating system in there. And with this heating system and the convection that you have, it's all the dust still has been there on a Monday morning. But generally, for 1 micrometer particle in a perfect room with no air movement, it's 7 hours. And that really shows you how much of a problem this can be. And this also showcases you a question that we really often have is, can the dust light tell me if I can, when I need to put on a mask? And we say, absolutely, but it can tell you one thing that's even more critical. And that's the big thing. When can I take my mask off, right? Because if I start my power tool, my sander, or if I'm starting to cut concrete, it's fairly obvious that now I should be putting on a mask. The much bigger question always is, when can I safely turn it off? And usually it's not when I turn my power tool off, right? That's the moment where I take off my safety goggles and my earplugs so I can chat with my colleagues. But with the mask and with dust, it's really something completely different. And this brings us to our next topic, and that's silica. I mentioned in the beginning, silica is something that people in Australia or like the regulatory bodies really did a great job over the past few years in trying to raise awareness. I'm pretty sure most of you have heard that I think you call them synthetic stone or artificial stone countertops for kitchens have been completely banned due to the threat of silica. And with this short deep dive, we really kind of like want to give you some insights what silica is, why it can be so dangerous, and really kind of like help you to evaluate your risks with silicas. And crystalline silica is something that can occur with many different work steps, right? If you're cutting, if you're drilling, if you're grinding stone or mixing concrete, those are usually the most common things where you can get silica dust. And this really is from mining industry to construction. There's to tunneling. I think in Sydney with limestone, with the tunneling project in Sydney with limestone, you have a huge silica topic going on right now as well. And why it matters is that usually with those work steps, you're able to generate really fine dusts, right? And everyone who's been drilling concrete for a bit knows how fine this dust can be. And those particles are especially small, that makes them even more dangerous, and they can go all the way into your lungs. And I showed you one of those silica particles under microscope. You saw this crystalline shape really gives it so many sharp edges and corners that it really can hurt the tissue into your lung and really can generate scar tissue over time with every breath, right? Your lung is moving, and those silica particles are pretty much pinching holes continuously into your lungs. And yeah, I think just by my explanation here, you're able to realize that this doesn't sound healthy at all. It's pretty much the contrast. And silicosis, lung cancer, COPD is chronic obstructive yeah, pulmonary disease is very common health effects that people have after working with silica over time. And this is why the silica levels are especially very, very low right now in Australia. That's 0.05 milligram per cubic meter for an 8-hour shift. There's a debate ongoing if you want to lower this or not. But yeah, so this level really showcases you how low those limits are. And when we talk about silica, we also often talk about quartz. On the right side here, you see a picture that I took a few years back of a quartz block in the Alps. And pretty much if you grind this up, you would get what's on the left, silica dust. And to show you how dangerous silica is, um, this tiny particle, if I'm sitting in my office here in our Dustlight office, this is the room probably 25 square meters. If I would throw up this tiny particle in the air right now in our offices here, we would be over the Australian limit of respirable dust for crystalline silica, right? This is how little amount you only need to get over this limit. And the reasoning behind this is not that that the regulatory bodies try to give you a hard time. It's the opposite. It's to showcase you how high this risk is. And for instance, if you want to protect yourself with any particle monitor, obviously your question will be, but what's my limit? How high is my limit? And if I wouldn't have told you how high the limit is 2 slides before, I want to showcase you how you can find the limits for respirable dust for your workplace, not just for silica, but really for pretty much all substances there are. And in Australia, there's a great website called Safe Work Australia with the WES, the Workplace Exposure Standards. And they have been launched last year. There will be a new document next year. And with this, you can really find this out. And because this sounds very theoretical, I'm shortly gonna switch my screen here to really showcase you how easy it can be to find this. So you can download this PDF on the website. There's also a link in the presentation which we're gonna send to you. You see a little kind of like a little table of contents here, and usually all of those have pretty much the same structure, all of those documents worldwide. There's a bit of an intro. It's really worth reading. In the beginning, it's sometimes a bit theoretical, but then really interesting. There's different standards and dust and size. And then if you go a little bit down, a little bit further down, you will get a list of exposure standards. And this means if we scroll all the way down here, you see this is where those lists start to come. This looks very technical in the beginning. What you're looking for is the TWA, your time-weighted average, in milligram per cubic meter. This kind of like will be the first thing that you look for. And if we scroll a little bit further down, or if you just search for it, just check here. We do have at some point a little section at S, it's page 42, which says crystalline silica, right? And you have different limits for those. Actually, those are all the same limits. For all crystalline silicas, be it quartz or tripoli, you can see here, hey, my limit is 0.05 milligram per cubic meter. For some other substances, you could also have short-term exposure limits, right? Those could be on the side here. It works the same if we do welding fumes, for instance, right? If we shortly check, here we do have welding fumes on the bottom here. You can see those are at 1 milligram, right? As a short reminder, here, this is a silica. It's 0.05 for silica. That really showcases you how low this can be. And even for welding fumes, this already is a very, very low limit. Actually, I think the limit for welding fumes, you can see here, has been lowered. This is kind of like what's new, what has been new. And this one has been lowered from 5 milligram to 1 milligram last year. Also showcasing you how dangerous welding fumes can be. Exactly. If you have any troubles, if you say, hey, I can't find the substances that I'm working with in this WES, always feel free to message your colleagues at Maxisafe or us at Dustlight. We're more than happy to help you find your limits for your dusts so that you can set up your devices accordingly. If there are any questions, feel free to write them down in our Q&A section. The most ones are, I think, about the Dustlight, and with this, let me just we come to our next section. This is where I'm going to hand over to my colleague Benjamin, who's going to tell you more how you can track exposure, how it has been done, and also how you can do it in the future with Dustlight and the existing solutions. Thank you, Benjamin.
Yeah, thanks for the handover, Tor. So also welcome from my side. And we learned so much right now about the standards on the exposure. And now we're getting a bit into it, how you can measure that. And there are mainly two different measurement methods. So I shortly go into that because I don't know who of you is familiar with you. So who already knows that can be prepared for the next slide. But we have the gravimetric sampling. That is the standard that is being used for the last decades. You have a pump that is pumping air through a filter medium. And in the end, you weigh this filter in a lab and you can analyze it. And if you divide the air that you pump through this filter by the weight that the filter gained, you get an average value of the dust that the air contained that you measured in. So you see on the left side, normally you put it on a person like this. So it's not that comfortable to wear, and it only gives you this one-time value. In the last few years, there were a few new optical measurements established. Optical means you mostly have a light source, so mostly a laser. So we, or those devices, measure the amount of particles and the size of particles and do this in real time. So they show it on this, if you look at this device, they show it at a small screen, and you get multiple data points of the dust. And this is a great new step coming from gravimetric based sampling, because you not only get this one average over the entire shift, but you can already start to see when you have your peaks in your measurements. But what is here still missing in just those two measurement things is when does it happen, at which place, at which workplace. So you don't really know what are my workers exposed to. And if we go a bit further, or look a bit further on the workplace exposure, you see how it's normally done to assess a workplace with those measurement devices. If we see on the left side, as I said, you collect the sample, you send it to a lab. This takes a few days. They need to condition it, they need to weigh it, and then they send you the results of the test. With that result, you want to change probably something. So if you get the result, everything's perfect, that's good, but normally that's not the case. So in those cases, you correct something, you install a new ventilation system, or you do some reorganization steps to minimize the dust. And what you're going to do then is you check a few methods to correct that were successful. So you collect again a day of sampling, send it to a lab, and you repeat that until you're compliant with the regulations. If we look at how to do that with optical measurements, so you still got it one day that you measure, but you get the results afterwards on a USB stick or something. You can look into that. You can take your corrective action, And then you can validate it again, look at the data coming from that measurement instrument. And as soon as this device says you're compliant now, then you do again like this gravimetric sampling to prove that you're compliant. This is one thing. This gravimetric sampling is currently the way how to measure it on a regulatory basis. So this is still needed. What you can already see is these graphs are going down a lot. So it saves a lot of time and a lot of cost already. But when we look at Dustlight, which also falls in this category of optical measurement, we're bringing that a step further. Because what you still need to do in the optical or in the classical optical sampling, you need to analyze everything. And this part we're taking away from, or we're not taking away from you, but we support you the best we can do with that. And this brings us a bit further on how Dustlight works on your work-based exposure. So how does it work? Real-time monitoring with Dustlight. We can quite easily put it in 5 steps on how Dustlight supports you. So as every other measurement instrument, the first thing is we measure the dust. So you switch it on, put it on your body, and it starts measuring. So you don't need to set or do complicated settings. You don't need to calibrate it before start. You just switch it on, put it on your body. And it detects dust around you, measures it, shows it on the screen as the number. So it's exactly the unit that you've seen. And then if this dust level is above the limits that you're allowed to have or that you should have, it alerts you. So you get a visual warning. It's like you've seen it on the pictures already. So as long as the device is green, you're within your limits. If it's turning yellow, you see, oh, there's a rising dust concentration, or I moved somewhere in your room, for example, where there's a higher concentration than in the room before. Or at some point it may turn red. This means that now you're really reached your limit. Those limits are, of course, settable from yourself. And with this, you have this direct personal protective side. On the next slide, you can connect the device via Bluetooth with our apps and then analyze the data that you or the device measured. And we do this a lot easier than current solutions on the market. But let's dive into that in detail. So that's the 2 stages. So we had the first 3 bubbles. They belong to the personal monitoring. So that's our first step for the workers out there that really are in contact with the dust. So they get the real-time feedback on their personal exposure at every time. I've seen that there was the question already. So we measure from 1 micrometer in size on up to 10 micrometer in size with the steps in between of 2.5 and 4 micrometers. So as Ted explained before, it's always the particles smaller are included in there. You get
if I can add something to this. We measure from PM1 to PM10, but because I think the question read, so what's the smallest particles it can reach?
Okay.
We actually start detecting from 0.1 micrometer, right? So this is almost in the nanoparticle size. So from 0.1 is the smallest particle that we can measure. So everything in your welding fume silica dust, all of this is included in there. Sorry, Benjamin, I'm gonna hand over back to you.
So yeah, so I still said that this will all be included in the PM1 section, but measuring much smaller than that. And you get the light feedback. You can also activate an acoustic warning if you want that, and all that in a small and very handy device. And then the second step, this will be also for you if you're interested in that, but this will also be mainly the use case for health and safety specialists who are interested in the exposure of the employees they care for, or that they are in their responsibility. You can analyze the workday. You can export all measurement data. You can export all analysis. And of course, it's all stored safely. And you can really look into there years later and have a long-term evaluation. So not just look into certain days, but really see it on a long-term basis for the year or for the month. And so you really have a basis to work on to reduce the further exposure. If we go a bit more into the personal monitoring, so how does the Dustlight itself work? So as we said, we have that 4 fractions of sizes that we measure, and with these sizes, we also measure the respirable dust. So that's a bit bulky word, how to know. Still explained how your lungs work. So the respirable dust are the particles that can reach deep into your lungs, into your alveoli. That's one of the smallest parts of your lungs. And particles that can reach or that can go in there are the most dangerous ones for your health. That's why we developed an algorithm to really measure those particles that can get in there, because it's a bit complicated to know it just from the sizes. And what the Dustlight also already calculates is the STEL and TWA exposure values of your day. So it really sums up over the day and says how deep you're into or how far you reached your limits already. How this works, you see that intake at the front. There we get in the air, pump it through the device and put it out on the left side here. This flow is made by a fan that's in there, and the airstream is then like light up by a laser, and based on how the laser beam is scattered. So we see, like, we have different photodiodes in there, and we can see how many particles are there, what size are they, and we know how much air we pump through there. And with those, we measure and calculate all values that you see on the screen and that you will later see in the air. And Dustlight has a few more perks that are not directly related to the measurement. So if we go one slide further, you see we have this active airflow, and this must be very continuous and reliable, and we need to know how much it is. So we are constantly checking for this airflow. So we have or can give you the concentration, because the concentration is in microgram per cubic meter. So we need to know exactly how much air goes through there. And from time to time, the device also starts a safe cleaning cycle. So if you're currently in a very clean environment, you will hear it. It will turn up the fan a bit and remove all particles that may have deposited in the device. The device comes with a click-fast clip. So with this, you can attach it easily to your clothing. If that's not enough and you have a job where you really move a lot, there's also a click-fast accessory available where you can really mount it stable on your body with like an arm strap or chest strap. The device is charged with a magnetic charger, so we don't have a USB-C port or anything there, because we made the experience the USB-C port lived for exactly a week in a workshop, and after that it was full of dust. So we have this magnetic charging port. You can easily wipe it off, clean it, and be ready for the next day. The battery inside is, depending on the mode, we have lots of hours of battery lifetime, up to 40 hours in the battery saving mode. And as I said already, it's a laser-based instrument that can measure the dust on a really, really small build area directly on your chest. And then
I'm going to totally jump into again, because we have many questions about the product, and I think with this overview, this might be great to really answer some of those. I think this might be a good place for this. So since the question got asked, as Benjamin mentioned, the battery lasts up to 40 hours. There are different measuring modes, and depending kind of like how bright you turn the lights, if your display should be turned on or not. It can be varying from 8 to 40 hours, right? But minimum is always one full shift, one working day. But if you use it in eco mode, is what we call it, where the screen turns off within, I think, 1 minute. And then if you can wake it up by the press of a button, but then it lasts up to 40 hours. Another question that we have had around for the product is how far does the Dustlight measure in terms of space around the person? And I think that's a great question. And to answer this, this is something which you can't really determine. It's very similar to gas. This really depends on if you do have any airflow, right? If you imagine if you are in a on a tunneling construction site, I think that's always a very vivid picture. And there's a clear airstream moving in one direction, right? So what's behind you pretty much doesn't matter, but only everything that's kind of like gets blown onto you. And also dust has the characteristic of really concentrate into like little clouds, right? And so we always say that's why you should be wearing the device, why it's a personal monitor, right? You shouldn't put it on your workbench and then it's sitting there, but really it's a device made to be worn so that you can protect yourself. And the closer you have it technically to your nose and your mouth, right, the more what measures correlates to what you breathe in. Then we have the question, what is the weight of one of these units and how robust is it to exposure to mining environments? And so the weight is, Benjamin, correct me, you know this better than I do, but it's around 140 grams. So we're always joking, it's like a candy bar, right? Like a bar of chocolate. So it's very lightweight actually. It's really made to be worn, as I mentioned before, and that's also why it's very robust. The gray area around here is a like a silicon sleeve, like a TPU sleeve, similar to what you would have on your Android phone or your iPhone, to protect it. So if you drop it, it's very robust. We really try to build a device that's not like your usual lab equipment, right? That you need to kind of like put on gloves to work with it because it's so sensitive. But it's really, yeah, very heavy duty device that's made to be worn day in and day out. The next question, and then Benjamin, I'm gonna hand back over to you.
Yeah.
After two more questions, then we try to answer the rest at the end of the webinar. Is can the device get wet? And you can imagine we need to suck in air here and blow out air on the other side. So you can't drop it in water or anything. If they get some water mist on it because you're cutting concrete slabs or something, this is fine. But it's not rated to be used underwater, pretty much. Exactly. Benjamin, I'm gonna hand back over to you.
Yeah, we're also looking to answer like all incoming questions in the end. Great to get so much feedback and so much interest in the product itself. So really great. But first, before we come back to the product, a very big part of our entire Dustlight product offering is, of course, what you do with the data. And for that, we got our software. And if we go into that, you see it already here. We got a mobile app that's available for iOS and Android phones and tablets, of course, and also in the web browser on all computers that you have that support Bluetooth if you want to connect with the device directly. So let's dive into that. On the software, the first thing you got is you got a real-time dashboard showing you exactly what your Dustlight does. So you connect via Bluetooth, and as long as you're in the range of the Dustlight, it's around 50 meters, depends on if you're indoors or outdoors. You can see all the data live on your screen and see the warnings also immediately. But all the data is then synchronized to your computer or phone, and you can look at it anytime, even if the Dustlight is switched off at another place or in your locker. You can then open the app at any time and check your dust measurements of the last days, of the last week, whatever you want to. Of course, in some cases, you also want to document it in other places than the Dustlight software itself. So you can export the data either as a CSV file. So if you want to do some analysis on your own, you can get those. Or we also support a really deep insighted PDF report. So you get all the statistics that you have in the app, like the STEL and TWA analysis. If your work day was compliant with the regulations. And you can also add tags where you say at this timestamp I was doing this job. All of that can also be exported in PDF form. So for example, if you're health and safety professional or doing it as a customer's place, you can hand out this PDF report later on. I already shortly said it before. All limits for the yellow, for the red warning can be customized. So in the first step, you choose the country you're using the device in, and you choose the material you're working with. And from that, it automatically gets the limit values. But of course, we don't have every material in there. So in most cases, you should set a custom limit, and especially for the yellow warning. So some people prefer to get an early warning. Some people say, hey, that's too early for me. I want to get a bit later. I just want to get it at, I don't know, 50% of the limit value. You can set all of that as you like from our software. And the last thing, as I said already, you get this entire reports on how compliant you are and how your exposure compares to the regulations. So we also got a slide on that. Here, you see, this is an example of a workday. So you see all the conditions that are there from regulatory side, and you see based on your measurements if you were in there. So probably a lot of you work with STEL TWA on a daily basis, and you know it's really complicated to calculate all of them. So the TWA, it's the long-term exposure across the work shift. So it's a average every few minutes, and the STEL, it's more about really short peaks in there. But then there's the regulation on how many peaks you're allowed to have, how long one of those peaks is allowed to take. And then there's a minimum distance between peaks. And all of that exposure analysis, our software does for you and gives it to you in this really easily understandable form, so that you don't necessarily have to be a expert in work safety to understand it and see what went bad on your workday, or what went good, or what are the problems. So that's really a short insight into the software, what it can do. So it's really powerful, and I'm pretty sure Maxisafe will be happy to tell you more about the software in the future if you reach out to them. And with this, I think we're coming to an end of the presentation itself, and are now all ready for your questions and happy to answer them.
All right, Benjamin, thank you so much for that little overview of how the Dustlight works and how the software is working. And yeah, we have 10 minutes left and got lots and lots of questions. We try to get through all of them. So let's dive right in. One question was, can Dustlight track multiple team members with multiple units? Absolutely. So this is really what the software is for. You can have multiple devices. You can give one device to each colleague, and at the end of the day, you can check how high the exposure has been. So this is exactly what the software then can be used for, to really kind of like analyze the exposure for an entire team, not just for a day, but also long term, right? So you can check also for month and quarter how you have performed. The next question is, the problem we have currently is that these samples we collect do not provide feedback on the spot to the user, and thus are not able to address the issues there and then. I think that was talking about gravimetric sampling, and absolutely. So really, usually, if you do gravimetric sampling, you get the results back a week or 2 weeks later, depending how quick your lab works. And then it's really tricky to kind of like act upon that data. And with Dustlight, you see I have one here. There's always a little test you could do to check how good your dry cleaner has been working, right? So if you rub it on your shirt and you look at the screen, the numbers go up instantly, right? Now it turns even yellow. Now the numbers go back down. So it really measures continuously and instantly, and gives you direct feedback that you can then act upon. All right. Next one is, how would it measure welding fumes and silica exposure for the same person at the same time? And that's a great question. And so we do not detect, hey, this is welding fume, or we do not detect, hey, this is silica. Usually that's pretty clear to most users, right? When you're welding, those might be welding fumes. If you're cutting concrete slabs, if you're polishing concrete, the dust around you is most likely to be silica. And so how it works, with the laser that we shoot onto the particles, it doesn't matter if this is a silica particle, if this is a welding fume, if this is a wood dust. We measure the size of the particles, and then with the different configurations, with the different substances that you can select in the software, you can really kind of like get more accuracy on the density of the product, so that we can kind of like showcase you the unit of milligram per cubic meter. And with this, we can measure the same units in the same size instantly, right? The next one was about the app. I think this one got cleared. Does the user require the app for data transfer? I think that's Benjamin mentioned before, you can connect the device with your mobile or with your laptop, and then it pulls all the data, stores it in the cloud for you, and they can access it. It also stores the data on the device, so you don't need to connect it every day. It's enough if you do this every 2 to 3 months. If you connect it, pull all the data, and then the device stores the data as well. All right. Then I think we get more and more questions, so I'll try to group some questions now. Um, there is one about a pump flow rate. Our flow rate is roughly 0.2 liters per minute. The flow rate for us is not as critical as it is for gravimetric sampling. I guess the person knows a lot about gravimetric sampling, where the flow rate is one of the most essential things. Since we don't pump air on a filter, this is not as critical for us. Our flow rate is very continuous here, and it's active flow rate to suck in air. One question that's coming up several times now is asking about explosive zones, if it's intrinsically safe, hazardous zones. So right now, the Dustlight is not intrinsically safe rated. We are working on a solution. We do have multiple customers that use it in intrinsically safe or explosive zones, where usually your on-site safety manager, and there's the different zones, right? And you can use it for several zones. For instance, if this is a gas explosive zone, you can use the device if you wear it next to a Draeger air quality monitor, or Blackline safety air quality monitor, or whatever you have. That's measuring the gases, and up to a certain limit, then you're allowed to use the Dustlight, also in a intrinsically safe zone. But obviously, this is always up to the materials that you work with and your site managers to file for an exemption here. All right. Pardon me. Let's try to go through some more question. The physical size of the product. It's I think 95 millimeters to 95 millimeters, so 9 centimeters to 9 centimeters, and then roughly 3 centimeters in width. So it's a very small device, right? Very similar to your gas detection devices that you would have in mining industry. We always say to people on constructions, it's pretty much the same size of a tape measure, right? If you have a tape measure clipped to your belt or your workwear, it's pretty much exactly the same size for this device. All right, Benjamin, do you see any
Yeah. Was checking it, lots of intrinsically safe questions. What I found interesting is, will the device continually measure during your 8 to 10 hour day and calculate your TWA? That's exactly what it does. So if you wear it on your body, it will take a measurement at least every minute of your day. And in the end, you see the real-time graph and you see the TWA, and you get all this workplace exposure data in your software. So that's exactly the use case for Dustlight, that you can do this on a daily basis.
All
and
right,
then we
I'm gonna do the next question. How often does it need calibrating? That's a very good question as well. So first of all, the device has several technologies inside to check itself if it's if the calibration is off, if the fan is not flowing right. The same thing what you would have for a calibration of your gravimetric sampling, right? Where you have like the airflow calibrators. So the device does all of that self-checking itself. The sensor in here is pre-calibrated, and we do have different configurations for different substances as well, and that you can choose from in the software. And there is yearly maintenance, right? So once a year, you would send this device to our partner Maxisafe in Australia. We do have partners all around the world, so if you're located somewhere else, we can also hook you up there. But in Australia, this will be Maxisafe, and you can send in the device, and then usually within very short amount of time, and they swap out the sensing unit with a newly calibrated one, and then send it back to you. So within days, you're good to go again, and you have a newly calibrated device. The device itself, as well as the software, also tells you, hey, in 2 months there is a service coming up. Book an appointment here for it, right? And then you just send it back, and it's very smooth process. But the device itself really always makes sure that it's functioning properly with every start of the device itself.
We got some questions related on capacity or memory capacity. So on the device itself, we have, I would say, up to 3 to 4 months. It always depends on if you use it really 10 hours straight a day or just a bit less. But that's a rough estimate you can use, but it will also notify you when you reach that limit that you please connect it with your app. In the app itself, you have the cloud storage, so you have unlimited storage with the cloud. You can use as many devices for as long as you want. So there are no limits. So you can really use the device every day. Don't need to take care about, oh, is it too much data? So there you really have as much storage space as you wish for. And also we had this limit value. When you set it in the app, it's transferred to the Dustlight, stored on the local storage of the device, and of course it remembers that the next time you turn it on. So if you want to change it, you need to connect it again, but until then the device of course remembers all settings that you made in the last session with your app.
All right, then we have the question, is the Dustlight suitable, effective outdoors? Short answer, absolutely. You can use it outdoors as well, unless it's pouring rain. Obviously, then with any electronic device, it's not too good to be soaked in water, but you can use it outdoor.
I think we have to hand back now to Maxisafe's side.
Absolutely. Or Hazel, you can tell us if we can, if
So
the crowd is.
I think we've got an hour's worth of activity booked. So
yeah.
I just want to thank everybody so much for joining us today. Thank you especially to Till and Benjamin. That was really insightful, some great learnings there. But what we've also seen is there's a lot of questions. So we haven't had a chance to get back to you all today. So we will follow up and directly come back to you and answer those questions. We will also make this webinar available to you all and email that through in the next few days. We would recommend that you reach out to us with any additional questions, as we understand this is a complex issue, and we think Dustlight really does solve some of those challenges that we have around dust monitoring. So don't hesitate to reach out. You can contact us at marketing@maxisafe.com.au. We thank you very much for your time, and we look forward to hearing from you again. Thanks all.
Thank you very much. Thanks for the questions as
for
well.
hosting us.
Have a great afternoon, everyone.